Welcome to a lesson with Dr. Powell. Let's look at an example of using the ratio test to check for convergence or divergence. Okay, so what we do is we think an plus 1 times 1 over an. We're looking for the ratio, how to get from one term to the next when we multiply. So we're going to get rid of the current thing by multiplying with the reciprocal, and then we'll have the next thing. All right, so the idea is we just simply take this as is with n plus 1 plugged in. Okay, so we can do that. So n plus 1 cubed plus n plus 1 on the top. And then we have times 2 to the, now when we put n plus 1, that'll become n plus 2. And all of that is over n plus 1 plugged in here becomes n plus 1 minus 1, which would just be n. And then here, this would be -3 to the n plus 1. Over here, let's see. Okay, so that's this first part. We just take this and plug n plus 1. Now we just take this as is and take its reciprocal. So n minus 1, -3 to the n, all divided by just this on the bottom, n cubed plus n, 2 to the n plus 1. Okay, now notice that we can cancel some things. This is n plus 1 twos. You have n plus 2 twos. So you should have 1, 2 left, right? All right. In factors. And then here you have n -3s, and you had n plus 1 -3s. So you should be left with just 1 -3. Okay. Down on the bottom. All right. And then we have the rest of it. So you have 2 over -3. Now, one thing to keep in mind is that this is a absolute value test. So this tests for absolute convergence. So in this ratio, we take the absolute value of it. So then we'll ignore this plus here, or this minus, and make it a plus. Okay. Then we just have a polynomial over a polynomial times 2/3. So we can factor the 2/3 out. And then we know we have absolute value of polynomial over polynomial. The top polynomial, let's look at it. Leading term, like what's the biggest term when you expand n plus 1 cubed? We're going to get an n cubed. And then that's going to be the leading term here. And then we're multiplying it by n minus 1. So n cubed, and n would be n to the 4th. So this will be like n to the 4th plus something. On the bottom here, think n times n cubed. Okay, that's leading term is n to the 4th plus something. Now, L'Hopital's rule, repeated usages of it will get rid of the lower terms before these terms are done away with, which means the limit just depends on these guys. So if you had n to the 4th over n to the 4th, and that limit's just 1. So hence, we get that this limit, so this limits to 2/3, which in absolute value is less than 1. All right. So that means that this series absolutely converges. So not just conditional convergence, but absolute convergence. So this series converges absolutely. Now it is true, the series converges absolutely. It'll also converge conditionally. The sequence of partial sums will also, well, because if we just make everything positive, instead of bouncing around in the partial sums, but we just push everything up here and that converges, well, definitely that's more an absolute value than it would be if it was bouncing around a little bit here in some sense. And so we actually get conditional convergence as well. So absolute convergence is pretty powerful here. Converges absolutely. Thanks for watching.